Well, good morning. I'm here with Brian Beesley, who leads our data science practice. Brian, tell us a little bit about yourself before we start interviewing you, but we're going to talk about machine learning today, and I'm so excited to talk to you.
Yeah, so I've been with CCG for just about a year now. I've been in consulting, though, for 7 years, focused primarily on everything from data management through reporting and then, of course, predictive analytics. Most of my background has been in the financial services industry, though I've had projects all across consumer goods, industrial goods, as well as healthcare.
Excellent. So today we want to just talk to you guys about machine learning. We want to make it really simple, and Brian's really good at doing that. So, Brian, can you give us a simple definition of machine learning and what it is?
Sure. So traditionally, when we do computing, right, we tell the computer exactly how to answer the question that we want to have answered. So for example, we might say, you forecast this month's sales by taking last month's sales and averaging that with the sales for this month last year, and then that gets you this year's estimate or forecast. Machine learning is different. What we do instead is we start with kind of a random solution to that problem, which is usually pretty bad. But then what we do is we tell the computer, how do you measure how good or bad that solution is? And then we tell the computer, how do you update that solution just a little bit so that it improves, right? And then we let the computer loose on just tons of data and let it update itself a lot. And the thinking is that because a computer can handle a lot more variables and a lot more data points, right, it will find patterns in the data that a human expert might have missed, and ultimately it's going to come up with a better solution than we would have come up with if we were just feeding it what we thought was the right answer.
And how long does a process like that take?
It really depends on the use case and on the amount of data that you've got. Most training iterations are going to take place over the course of hours, maybe overnight, and then you'll kind of see how well it did. And then if you need to try it again, right, you can tweak things and update. Its measurement, where it's deciding how good or bad its current solution is. You can update how it updates itself. There are lots of things that you can kind of tune to tell it, so that it gets a better answer next time.
Excellent. And it's been around a long time, right? Since 1959, machine learning is not something new. Why don't you tell us a little bit about the history of machine learning?
Yeah, so machine learning is not new. It has been around. The concepts have been around for a long time. In fact, some of the more advanced techniques, like deep learning, is getting a lot of buzz right now. Well, those techniques were invented in the 80s. So again, we're not really dealing with huge breakthroughs in math currently, right? What we're dealing with more so are changes in the way that we're able to apply those things, right? So historically, there just wasn't nearly the volume of data that we have today. I mean, you think about the amount of data that people are collecting from web browsing activities or from IoT sensor data. There's just tons of data now that we can use. And that is going to improve your machine learning applications in a couple of ways. Number one, it really opens up the amount of use cases that you have available, right? And number two, the more data you have, the better the machine can learn the problem that you put in front of it. So that's been one of the biggest advances. It's just been the amount of data that we have. The other one is the improvement of our hardware, right? Computers in the 50s weren't great. Computers in the 80s weren't great, right? Now we've got machines that can just do exponentially more than our computing was doing back then. And so a problem that used to take weeks to train could now train overnight or in a matter of hours or minutes. And a lot of that comes down to just the hardware architecture with things like graphical processing units. So thanks, video gamers, right? As well as kind of cloud computing, right? Where you can elastically scale your compute, right? And say, okay, we're doing a training cycle. We need a lot of computing resources, right? And then once you've kind of learned what the right approach to a problem is, then you can scale it back and feed it through a thinner computing architecture to get your predictions from then on.
What about the organizations that worry that their data is not where it needs to be in terms of data quality? What would you tell them, and how can they use machine learning? Can they still use it?
Yeah, you can still use it. I mean, So there are a couple of things to talk about from that perspective. First, data scientists in general don't talk so much about ETL, which is sort of the traditional extract, transform, and load your data exactly how you want it, so much as ELT. So they bring in the data and then they see what they need to do to it to fit the problem at hand, right?
Excellent.
And so a good data scientist is gonna bring the data in, and then before they even start training the computer, right, they're gonna start looking at the data in great detail with scrutiny to say what's missing here, what don't I understand about this data, what do we need to fix before we can use this really for the machine learning process. And a good data scientist will really collaborate with the business on getting
Perfect.
that stuff right. The other thing is, it might turn out that your data doesn't adequately solve the problem, and that's okay. You can get learnings out of that.
Correct.
You can go find out what you need to do to go update your data. In fact, I mentioned the ELT process. One of the best outcomes of that is, okay, once you've extracted and transformed your data, as a data scientist, you can bring that back to the business and turn that into a traditional ETL sort of, right, approach where now you've got the data stored in the way that it needs to be consumed by the computer. So you can take sort of that exploratory analysis and then formalize it later. Another thing to touch on as far as that question goes is, if your data isn't really there to solve the problem that you've got, you can still get a decent solution. It just might not. It just might have more variance in your answers, right? So maybe
you have to go back and continue tweaking and
right. So if you've really got the data, you might say, hey, we can make this prediction within a 2% margin of error, and if your data isn't quite there, maybe we can make the same prediction, but it's a 10% margin of error, right? And you just need to make sure you understand kind of what those parameters are, and that you're using the outputs of your models responsibly given the amount of variance in your outputs.
Perfect. So for those new to machine learning, what are some current applications of machine learning that they would recognize that are out there today?
Sure. Yeah. So I think a big one that people see a lot is speech recognition, right? So you look at like Siri, right? You speak to your phone and it transcribes that into text, and then it understands that text and it answers your question. That's a series of machine learning algorithms that are playing out one after the next. So first, the speech recognition, right? Taking what you said and turning that into text that can be understood by the computer. And the way that works, that's a discipline of machine learning that we call supervised learning. And what we mean by that is that we've actually provided the computer the correct answers. And we've labeled the data so that it can learn the patterns that it needs in order to make sense out of the speech. So someone would speak into a microphone, and then the computer would turn that into a waveform, and then the computer would be told this waveform represents the word cat, and this one represents dog, and this one's cracker, and this one's tree. And eventually, once it's got enough of those waveforms to read from, and it's got enough of those right answers, it can start to learn the patterns. This represents the consonant C, and this represents the vowel E, and then it can cobble those words together, right? And then once it's got it into text, then it goes through another machine learning algorithm to say, okay, what does the question that I've asked, Siri, tell me the weather today, what does that mean? And so you can kind of cobble them one on another. Another one that people think about quite often is Google search, right?
That's a huge one.
Yeah, the way that works is basically it's ranking websites out on the internet based on your query words, right? What other people have searched for in the past, and then it can kind of again label itself based on whatever search results you actually click on, right? These were the actual websites that were of interest, given the words that were input into the search bar this time. Another big one is kind of recommender systems. So I always think of Netflix.
Right. Absolutely.
Right? Yeah. So the way that works is they use a lot of collaborative information. So viewers with similar viewing patterns as you are rating titles, right? Did I like this TV show or this movie, or did I not like it? And so what they're doing is they're going on to find viewers with similar viewing patterns, and then it's going to recommend the same things to you, and then of course you can go back and label it yourself and say, yes, I did or didn't like this, and then that's going to update its understanding of your preferences and, you know, sort of whose preferences it uses to make recommendations to you going forward.
And we love all those applications. So machine learning is very powerful and helpful in many different industries. So let's talk about the application-specific industries. Let's start with the retail industry. How would you use machine learning in the retail industry?
Yeah, so this is good because I think a lot of people see those really big and exciting use cases, right? And it's hard to think, how do I bring this into my business and make it useful, right, and practical? You know, I'm not doing a recommender system, right? So, so in the retail industry, you know, there are lots of potential use cases. For example, you know, I mentioned earlier forecasting sales, right? That's a pretty typical one. You could also do supply chain analysis in terms of all kinds of stuff. You know, geographically, right, route planning your drivers to get from a distribution center to a store. You could talk about segmenting your customers into different groups so that you target your marketing you know, to the type of customer that they are. Right. There are gosh, there's another one I was just thinking about.
Stitch Fix, I believe, uses machine learning. I don't know if you know who Stitch Fix is. It's a company that targets women, and it picks your clothes for you, and it learns from just like Netflix, you know, from other females who have the same taste, and then it sends you specific clothes to your home that you would like. Yeah,
and recently I've been getting bombarded with, you know, advertisements for a wine company that does that, right? You take a quiz, and then they get your wine profile, and they start sending you bottles, and then they update your preferences. Yep.
Exactly. Yeah. All right, so let's move on to the next industry, manufacturing. One example there, please?
Sure, yeah. So manufacturing. So I mean, I'll just, from personal experience, recently I did a project with an industrial goods company where they were melting scrap metal into steel, and you know, the way that they determine the quality of the steel that they get, you know, at the end of the melting process is they have to wait until it's liquid enough, and they can stick a probe in there, and it measures, you know, the quality of the steel. Unfortunately, they have to wait until near the end of the process in order to do that.
And that's a lot of money to get that far.
Right. So by the time it's gotten that far, I mean, if that scrap metal wasn't going to make good steel, they could have tossed it and started a new batch.
Correct.
The operators might have been able to tweak some things and you know, sort of burn out the slag, if you will, right? To improve the quality of the steel. So they were looking for can we get a better read on how good the steel is going to be? Well, they had tons of sensor data, and so so we were able to use their sensor data to find the most important, you know, pieces of information, so that we could begin predicting the quality of the steel as early as 5 minutes into the melting cycle.
Wow.
That's
and
so
huge
then they can
cost savings and gross margin.
Yeah, so then they can go back and integrate that with their dashboards, so their operators know, you know, should I continue with this melting process? Are there things I can do to adjust, right? And there are ways you can go from there.
How long did it take you to get to that point where you were able to save them all of that time?
Well, so their data was pretty clean, which that's usually one of the biggest time sucks of a data science project. So that particular project was about 3 weeks, but I was part-time on it, so yeah.
Still, I mean, amazing ROI for 3 weeks of revision of data and some machine learning, so excellent job. And then the financial industry?
Yeah, so this is where my background is. So the financial services industry has been using traditional statistics for a long time. You know, and the thing about it is that traditional statistics, you can get some of the good ROI, but it's costly to get there. It's time consuming to get there, and especially in financial services where regulations are so high, right? And you're dealing with so much uncertainty, right? People get pretty skittish around the statistical applications in financial services. You see it a lot now with robots doing trading, right? So
They're doing most of the trading from what I read nowadays.
Yeah. That's definitely true. I've thought about converting my own portfolio to be automatically traded, but I still want to have that control. I do have machine learning applications telling me within my portfolio what I should buy and what I should sell. But then I go and make the clicks myself. I'm old school like that, I guess. But there are opportunities to grow, I think, particularly in kind of the risk and regulatory compliance space. Identification of fraud is a big one, as well as money laundering identification. That's a big one where I think there's a lot of regulation around it, and currently a lot of the processing is pretty simple business rules, right? If it's over this threshold or under this threshold, then we're going to flag it for fraud, right? There's a lot more nuance than that, and I think that there's a lot of opportunity for machine learning to get into that space.
Excellent. So we talked a little bit about the cost savings and the gross margin increase with your one machine learning example that you gave us about manufacturing. In general, what's the ROI on machine learning?
So the ROI, that's a big question, and it depends on a few things, right? So it depends on your ability to identify use cases that are going to be helpful and profitable or cost-saving. It depends on your organization's willingness to move from more gut-driven decisions to more data-driven decisions. But if you can get those things right, I mean, the potential for ROI is massive. So I'll stick with banking for now because that's kind of my world. The number of bank branches in the U.S. is down 10% over the last decade.
Physical branches.
Physical branches, right?
Moving
and that's
to a virtual
huge
branch,
right? That's a huge component of cost in the financial services, right? Or it was, right?
Absolutely.
So and the reason that they can do that is because now you can pull out your phone and deposit a check online. You don't have to go to a brick and mortar branch location, right? And the way that your phone can do that is with optical character recognition, which is a machine learning application, right? So it takes a picture of the check and it says, we think that this is a check for $172.50. Is that right? And so we can take that out of the branch. Okay, great. What else do you have to go to the branch for? Well, we've got to apply for a loan. Well, now you can apply for a loan online and get underwritten in an hour, right?
Absolutely.
You don't have to go to a branch to do that. So there are all of these things that are being done sort of behind the scenes with machine learning applications that have made it possible to get away from this physical model that's, it's really disrupting the industry. If you're in supply chain, think about, wouldn't it be great if you could reduce your inventory because you have a better idea of what your demand is going to be? I mean, I guess bottom line is
or have a smaller store because people can come in, touch the goods, and then buy online. So instead of having a 4,000 square foot store, now you have a 1,000 square foot store with a sample of goods.
Sure, yeah, and you're starting to see Amazon open physical stores, right?
Exactly.
It's sort of that reverse, right? But they've found a way to...
we still need to touch and feel, but we don't need a store in every corner.
We're still selling to humans at this point,
exactly.
right?
At this point.
Right. But I guess the bottom line is, to the extent that you can have, really good decision making, right, as if it came from one of your human experts, available instantaneously and 24/7. To the extent that would improve your business, that's your ROI.
Excellent.
Yeah.
Excellent. Well, thank you so much for your time today. This was very enjoyable, and I always learn something new every time I speak to you. So thank you, Brian.
Good. I'm glad.
Thank you.
Thank you.